This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support. 2.5 Admins, episode 287. I'm Joe.
I'm Jim.
And I'm Allan.
And here we are again. And before we get started, your customary Clara article plug, Allan, is OpenZFS monitoring and observability.
So this week, we got another article from Jim talking about how you can keep watch over your ZFS pools and make sure that not only is the pool good and all your hardware is healthy, but make sure the snapshots are getting taken and that they're getting replicated to where they need to go, and tracking all of that and how to do either very simple monitoring all the way up to more complicated, and making sure you're keeping an eye on everything that you need to watch.
Right, well, link in the show notes as usual. Western Digital recently had an event called Innovation Day, and they gave us an update on some hard drive technology.
Yeah, so there's a couple different things in here. You know, they talked about their path to the 40 terabyte Ultra SMR drives that are coming out shortly, and how they're going to eventually get to 100 terabyte drives. But in particular, they talked about their new high bandwidth drives and their dual pivot design. So the first one is designed to give twice the bandwidth as hard drives have now, and then possibly in the future up to 8x that bandwidth, and how they're looking at getting 2x the current IOPS out of hard drives by basically dual pivot is similar to dual actuator, or is dual actuator, just a different technology. And we saw the Seagate Mach 2 drives come out a long time ago, but now Western Digital has a thing, and it's going to be interesting to see if they approach it differently and how they deal with the fundamental problems of trying to have a hard drive that has two sets of heads and can try to get more IOPS by reading from different parts of the disk at the same time. Because how do you make that work with the operating system, the applications that people already have that kind of expect the hard drive to be more single-threaded?
And also, how do you decide where the data is going to be? You'd kind of have to preemptively know that it's going to be in the right places for two heads to read it at the same time, wouldn't you?
Kind of. So what the original Seagate design did, and based on the small amounts of text we got from Western Digital, this is probably the same, is they used a SAS technology called dual porting, where one hard drive can actually connect to two different computers for like a failover situation. Except they would do that where it was basically your 20 terabyte hard drive would just show up as two separate 10 terabyte hard drives. And the one set of heads would be the first 10 terabytes and the other set of heads would be the other. And it was up to you and your file system to decide how to use that to get the advantage out of it. And so like if you're doing ZFS, if you're going to do a RAID array out of it, you'd have all of the first set of heads of your 8 drives be one VDEV, and all the second set of heads out of those drives be the second VDEV, so that if one drive fails, it doesn't take out two parts of the same VDEV. But yeah, Joe's kind of identified the biggest problem. Like you can think of a couple different basic ways that you might try to split up a hard drive across these heads so that it would just work with existing file systems. But if you think of the very first thing you think of is like, well, if we just do every other sector on the opposite heads and actually just map them out differently on the disk, well, then you don't end up getting any more IOPS because the heads are always good. Like if you're sequentially reading a file, you're going to be jumping between the two heads and they're always going to be tracking with each other, reading every other block of one file when you're playing a video or something, and you're not going to get any more IOPS. If you just do like the first 10 terabytes and the second 10 terabytes of the drive, most operating systems, like Windows, for example, tries to kind of fill the drive from the beginning to the end. So the second head's not going to do anything and not going to give you any more bandwidth or any more IOPS until you're writing the second half of the drive. And it would be worse than drives are now. And so how do you have existing software and operating systems work with drives that are actually acting more like two drives?
I'll be your Huckleberry. I got the answer to that one. You treat the hard drive like it's a solid-state drive. Solid-state drives have the exact same challenges. To get the full speed out of a solid-state drive, you need massive parallelization where you're reading and writing to multiple media banks at once, which is why a heavily fragmented SSD, even though there is no seek penalty, still has a tiny fraction the throughput of one that is not heavily fragmented. There's a controller in there, and it produces a virtual sector map that your file system uses and treats as though it were an actual physical address space, but it isn't. That gets mapped by the drive controller to the media. What we're really talking about here is a host-managed approach versus a drive-managed approach. And we see the same thing in SMR, which actually is also part of SSD technology. We don't really talk about SMR and SSDs, but they are all SMR devices, whereas only a few hard drives are. I'm sorry, not SMR devices. They're all zone-managed devices, what I meant to say. When you get into SMR on hard drives, that's when you start talking about zones, where you have to read or write the data in zones. There's a lot of management overhead. And in consumer devices, this is all drive-managed with firmware. And we are talking about actual existing consumer hard drives right now. Enterprise SMR drives can frequently be host managed, where a daemon running on the system is supposed to manage when you actually garbage collect and rewrite the zones, and can maybe do a more intelligent job of it than firmware can. But my point is that the drive side zone management, that's already a feature built into every solid state drive. I think there are certainly benefits to doing host management, which is probably why Seagate elected to go dual ported last time rather than building in, a controller to do it on the drive. But for consumers, yeah, just figure out a reasonably efficient algorithm, drop it on a cheap chip, and you're good to go.
Yeah, but what is that algorithm going to be? The problem with just doing it like a flash translation layer in an SSD is the SSD has no cost for seeking. But if you just have a dual actuator hard drive, you can maybe cut the average seek time a little bit, but you're still going to have that penalty for when you have to seek. So when you're writing a file, how does the drive decide how to split that up, knowing that I don't need to be able to read that file any faster. I just need to be able to read that file and some other file at the same time, but I don't know what that other file might be. And because I'm in firmware on the hard drive, I don't know which file's which. I don't know that they're files. I just get writes from the file system and put them in blocks on disk, and I can't guess how to lay them out in order to be able to get more efficient IOPS on the read side later. Because you have to predict how the user is going to use the files after, and there's not an easy way to do that.
There's not an easy way to do it ideally, but I suspect that with some time in the lab, you could absolutely write an algorithm that just basically worked on looking for a certain degree of pressure. Up to a certain degree of pressure, we're just going to kind of alternate between these heads as we write new data to the drive. Once you get past a certain amount, then you start, alternating probably by block count. I suspect there will be ways to figure that out. Keep in mind also that the drive is going to be presenting a virtual sector map if we're doing this drive managed. So the drive will absolutely know what the file system is intending to do with where it physically says it wants to put these files on there. So if the file system is trying very hard to make contiguous data on its virtual sector map, that's a really good indication that you should probably try to keep that contiguous on the actual hardware underneath as well.
Well, except ZFS does all of its writes contiguously, but it doesn't necessarily want to read them contiguously.
I still don't really get the objection because ZFS is trying to do contiguous writes when they should be contiguous, which means that the device that sees that's presenting this logical sector map that ZFS is writing, quote, contiguously, unquote, to, it can see, okay, well, ZFS wanted to write to, now on the ZFS level, we're talking about metaslabs. So, all right, well, we've got this big chunk of data in this one metaslab. At the same time, ZFS wants to write to a different metaslab, for a different process. Well, the firmware doesn't have to know that it's metaslabs in ZFS. It can just see, well, all right, the computer is trying to write two different contiguous blocks of data to different parts of this virtual sector map. That tells me how I should be splitting this up between the two zones that I have to work with. Is it perfect? No. Is it a whole lot better than nothing? Yeah.
Well, I think the biggest problem is just because we wrote them a certain way doesn't mean that's how we're going to use them when we read it back.
Now I think you're asking this drive to solve a problem nobody has ever solved with any type of storage.
True. I just say it's not that easy to do it on the drive side to actually get anywhere near actually double the IOPS.
Yeah, that's what I'm thinking. Like, just because you've got two doesn't mean you're going to get double, like anywhere near it, potentially.
Well, unless all you're doing is a benchmark where you're doing completely random 4K reads, you might get awfully close to the theoretical maximum IOPS. But any real workload, like unless you purposely did your writes to spread them across the different ranges, it could be a problem. But to Jim's point, if you had, what do they call the SMR? Host-aware version, where the drive tells the file system, these ranges of LBAs are on this actuator and these ranges are on the other, then maybe ZFS could do something where purposely, I'm going to make sure that when I'm doing writes, every transaction group, I'm going to write using both different actuators to try to maximize the number of IOPS for writes I have at any time to make sure that we're saturating both.
I think we're still going farther into the realm of perfection than we really need to. We don't need to get the absolute maximum possible utilization out of an extra set of heads in order to get a greatly improved result.
Well, it depends. Like if in the most basic ones, you're only ever going to use one head at a time or one actuator at a time. And so you're not going to get any more than the 200 to 250 IOPS you would get today with a hard drive that only had one actuator.
Again, you're trying to solve a problem that exists in every single storage device. If all you're doing is a single process read or write, you're usually not going to get a lot of acceleration out of any kind of multiple, because we're basically talking about a RAID array inside a single box. It has some extra concerns because there's only one set of platters with two heads rather than being two entirely separate drives. But you see this exact same problem with RAID arrays in topology. Depending on your workload, you may not get what you naively expect 6 drives will provide you instead of one. If you've got a RAID 6 array across 6 drives and you're doing a single process workload, it may or may not accelerate. If you're doing a multiple process workload, it may or may not accelerate because you may wind up with a lot of contention. It's going to be similar in this drive, but again, this is not a new problem, and I don't see why it's one that has to be solved for this drive to be worthwhile.
Well, because if the drive is connected via SATA or SAS, there's no such thing as parallelism.
There is inside the drive. It has its own controller. That's what we were talking about again. We're not letting the host manage the whole thing. We're doing drive management.
Yeah, but we're talking about the protocol. Like the host can't send more than one write to the drive at a time. All it can do is queue commands. And the commands have to complete in order.
Yes, but again, it can both queue the commands and it can indicate what blocks of data should be contiguous.
How does it indicate which blocks should be contiguous? There's no SATA command for that or SAS command for that.
Because it's telling you exactly what sectors it wants to write to. You've presented it with a virtual sector map. If it's writing a stream to the same sectors in the same area, it wants those to be contiguous. How does ZFS control where the metaslabs wind up on a hard drive, Allan?
It doesn't, but it doesn't write to like 7 different metaslabs every transaction group either. It tries to write only to one, to put everything in one giant 200 megabyte chunk all at once. Even though when you read it, you would like to use both actuators to read it back. So ZFS would need to have some way to tell the drive, please don't write this contiguously, even though I'm writing it to a contiguous range of LBAs on the disk. I want to be able to read this using both actuators later.
How many TXGs in a row are you going to get on the same metaslab?
Well, a metaslab is usually 16 gigabytes. So depends how fast you write 16 gigabytes.
I'm just saying, are you filling up an entire metaslab before you move on to the next?
Usually about halfway. It's expensive to load and unload metaslabs in memory. So we usually only have about 5 in total loaded at most. And yeah, we try to avoid loading and unloading them. So we try to get it at least half full and then go grab a fresh one and go from there.
Well, fair enough. I can see that, and I can see where that winds up being, it's essentially a similar situation with ZFS and SMR. ZFS suffers worse with drive managed SMR than older conventional technologies do, and it sounds like it would be likely to here. I do still think it's fair to say that these are essentially the same problems of it's not necessarily going to give you 100% efficiency that you were naively expecting, just like you wouldn't expect that out of a RAID array with multiple drives.
Right, but I'm talking like to get even a 20% boost in IOPS, I don't think most of these algorithms are going to work. Right? Like if you're thinking NTFS tries to fill the drive pretty much contiguously, and then it writes its MBT or whatever to the middle of the drive, which may actually be all kinds of hairy with it if you split your dual actuator drive exactly in the middle. But like it's generally only going to write to the beginning or the end of the drive at a time. Either the beginning of the drive is full and we stop writing to it and write to the second half or not. And so, you might have 2 heads or 2 actuators and only use one of them at a time for writing. And I mean, like you wrote with the first one for the first month and the second one for the second month. And so that means everything you wrote using only the second actuator, you can only read with the second actuator and you get no additional IOPS. And yes, something like a flash translation layer can try to remap stuff, but suddenly your hard drive needs a whole bunch of RAM to keep that flash translation layer in. And one of the things that makes SSDs and NVMe drives so much more expensive than hard drives is the fact that you need all that DRAM to store the translation table.
I suppose then our final takeaway is this, it sounds to me like what we're really ending up with is this is probably going to be niche hardware that makes sense in a data center with a very niche workload. But if you're a consumer at home, you're probably better off buying 2 hard drives.
It could be, although they're talking about a way to get 4x the IOPS. And I'm mostly wondering, have they figured something out? And I'd love more details. But, they have 4 sentences and that's it in this news piece at this point.
Sounds like time will tell on this one then.
A little bit. But there are probably use cases that can take advantage of it. It's just interesting to think about how we can do that.
I think the thing that I'm thinking the most right now is I have absolutely no desire to trial a new and very complex and probably kind of tetchy hardware technology coming out of Western Digital, who brought us the SMR NAS drive.
Let's do some feedback. Chris writes, in episode 280, a listener asked about performance of storage in their home lab. You replied that they should use a hyperconverged setup because of latency and thus performance. And Chris has a couple of points. The first one, haven't you previously condemned this pattern where people cram containers and services onto their NAS?
Yes, but here's the thing. When we condemn that pattern, it's when you're cramming containers and services onto teeny tiny, crappy little purpose-built NAS appliances, Synologies. This also applies to NAS distributions like TrueNAS. They're really, really locked down, and it's hard to get that crap on there, and they're not really designed for all that. The problem is not cramming containers and services onto the place where all your files live, hardware-wise. The problem is in asking a thing that's been very specifically designed to do a much simpler task to now take on all of your super complicated crap on top of it. Now, on the other hand, if you're saying, well, containers and services are very important to me and I want to build a machine that does that, awesome. And you can also have it serve your bulk files, which it turns out is basically the easiest compute task imaginable, pretty much. So you can just bolt bulk file storage onto your application server. You shouldn't expect just bolting an application server onto a bare bones NAS to go well.
Yeah, so basically, don't make a machine do something it wasn't meant to do. But if you're building the machine as a hyper-converged platform for your containers and your VMs, and you also want to run your file server on it, that's fine. But don't take a NAS distribution or an off-the-shelf NAS that's designed to be stripped down and do only the things it's meant to do via its web GUI and try to run your containers and stuff on that. And so taking a Proxmox and having the storage be local, or building a headless Ubuntu machine and having it be your hypervisor and your storage machine is totally fine.
I can't believe you're going to be the one to make me say or FreeBSD and Beehive, Allan, but
yes,
you're going to make me say it, and I said it, or FreeBSD and Beehive.
And I'm going to say or Ubuntu and Docker, like someone from 2026.
We're not going to say that.
We covered a couple of episodes ago, you could use the Open Container Framework directly on FreeBSD now.
Yeah.
True.
But the point is, build a machine for all the things that you want it to do. Don't try to cram a whole bunch of extra crap on top of one designed to do way less work when it started out. Obviously, this applies the most to like the Synologies and the, what's Netgear's thing? Ready Store? I can't remember what they call their thing. Something like that. These purpose-built NASs out there, like all of them are very, very weenie hardware-wise. They have got the least CPU firepower and RAM that the builder of the appliance figured they could possibly manage to get away with cramming in there, to the point that, I frequently see performance issues with NASs just doing file service, even though there's a 1 gig network as a bottleneck in the middle. So I'm not a fan of those. Obviously, that's the most applicable, but in my personal opinion, even when you get to something like a TrueNAS that has like built-in support for these things, it's really janky and half-baked and bolted on to a web interface as compared to the underlying operating system. I probably shouldn't keep calling their product half-baked, but by comparison with the actual operating system that actually provides those real services, it can't be anything but half-baked. IX Systems does not have the manpower, the budget, the hours that have been invested into the actual services for KVM or Beehive or, any of the, Docker, any of the containerization stuff. it's very Johnny come lately. And the idea is to be easy mode and save you learning how to do it the right way. But in practice, in my experience, it doesn't wind up being measurably easier. You're just now learning how to do TrueNAS's thing, and you haven't learned how to do it the real way. And you wind up with something with its own set of problems that just get tacked on to any problems in the underlying services.
Yeah, in general, a NAS distribution is literally about stripping things out of a general purpose operating system to make it specifically a NAS. And so if you want a general purpose operating system, use a general purpose operating system.
I've sounded really harsh about TrueNAS right now, harsher than I actually feel. And I do want to be clear about the value proposition that TrueNAS does bring. It's very easy for me to be dismissive of TrueNAS's web GUI and say that, you have to learn all these extra things to really master it that still haven't taught you how to master the services underneath. And that is true. But the actual value proposition is not for a single admin who wants to really discover what a server can do, needs to fully master that system and, accomplish everything. The real value add for a system like TrueNAS is when you've got a department and you've got senior admins and you've got junior admins. A junior admin can get a lot farther doing little simple things, within a framework like TrueNAS with a web GUI where all of the containers have already been set up and everything has been done right to get them all working together and properly. A junior admin can get in and do maintenance tasks and all that where they might be deeply confused without significantly more training on doing their junior tasks on the real system underneath. So there is a real value proposition there. I think that it's more for organizations with large departments with mixed skill levels than for like home labs where, let's face it, you don't have you are the senior admin, you don't have cavalry to call in. So, if you have to learn something to the degree of mastery because you don't have anybody to phone problems up to, I think it's better to learn the underlying system that does all the things and, is all you actually need when you are the one person who has to be the master of the system.
Chris's second question: doesn't virtually all enterprise infrastructure use segregated storage and compute? Is that only for reliability? How do the big clouds handle the storage? Do they simply offer lower performance in exchange for reliability? If not, at what scale do they need specialist hardware for a segregated infrastructure?
Firstly, a lot of enterprise stuff is very much promoting this idea of hyperconverge, where the storage and the compute are on one machine to get rid of that latency. But that is at a trade-off of not having high availability, because that requires the compute node to be able to fail, means you have to be able to load that same storage on a different compute node. And so that's why you often see the storage being separate, not because that is better, but because that's really the only way to be able to withstand one computer falling over.
I don't necessarily know that that's true. You can set up clustered but individually hyperconverged setups. I think that honestly, the better answer here is that you have to understand what scale means. And when you're talking about working at massive scale with potentially thousands of employees, you become willing to accept some pretty serious performance issues that can be worked around with money if it simplifies the operation, because you have got thousands of people who need to understand as much as they can about the part that they need to understand. Now, if you segregate your storage and your compute into different silos, that means that now you can do things like you can give the storage guys, they can have full reign over the storage side of it. They can tune it the way that they think it needs to be tuned. They can be the ones who own that, but they don't own the compute nodes. The compute nodes fall under a different team and they do the thing for that. And you can basically organize things into these smaller boxes you can assign teams to. Now, that doesn't mean that you can't scale hyperconverged stuff. You absolutely can, but you have to think about it a little bit differently. And you can't hyper-specialize your teams quite as much, at least not without having to give more people access to more sets of hardware than they otherwise would, which, again, it's not usually what you want to do in enterprise. You want to throw as much money as you need to at a problem in order to simplify the problem enough so that you can throw the cheapest possible labor at it, because that's going to be your big expense.
Yeah, and then for the big clouds, if you look at Amazon EC2, an EC2 instance usually has EBS, or Elastic Block Storage, as the storage, which is a network-based block storage. And it's different than S3, which is their object-based storage. And it's usually the EBS is closer to the compute, like in milliseconds away, but it's not in the same machine. And sometimes they mitigate that. Like when you're buying an EC2 instance, you can get one that has what they call an ephemeral NVMe drive. So an NVMe drive that, if the hardware fails, they'll migrate your EC2 instance to another machine and boot it back up, but the content of that NVMe will be lost because it was on the machine that died, not on the machine you got moved to. Whereas your EBS volume will still be there. And you can use that NVMe as a cache to kind of make up for some of the latency you get from the EBS or whatever. But even there, you can pay more for fancier EBS. There you get provisioned IOPS or whatever. You're guaranteed to get X thousands of IOPS to be able to meet your workload. So as Jim said, sure, it's slower, but you can always throw more money at it to make it faster up to a point where, you can't go faster than the speed of light and so on. But if you're willing to spend enough money, they will give you storage that much closer to the compute. But in order to get the durability, it makes more sense for the storage to be separate. But if performance at all costs is the game, then something where it lives inside the same machine is always going to do better.
And for your last question, at what scale do they need specialist hardware for a segregated infrastructure? The answer to that is a question, what do you mean by specialist hardware? I would answer that you need it immediately. You shouldn't even think about doing segregated silos for storage and compute unless you've got at least a dedicated 10 gig transport network. And I would argue that's already specialized. We're already talking about stuff, network cards with SFP plus bays on them and, fiber transceivers and, a whole bunch of nonsense. And you know what? It still won't get even close to the performance of a single SATA solid state drive. We're not talking NVMe. We're not talking about compute stuff, pulling, massive sets of numbers. Literally just the performance of a single consumer SSD, 10 gig can't keep up with it. So yeah, I would say that's the minimum and you hit it instantly. If you're thinking about doing segregated storage and compute on a 1 gig network at all, my answer to that is that has got to be only for experimenting to see how it works and what do these performance issues look like and, getting your feet wet with it. It's not something you want to do in production. And you don't even want to do that in production with a dedicated 1 gig, much less what most people are talking about in a home lab setup, which is just like, I got one big network and, maybe I have it carved into VLANs, but physically it's just one big network. And I do all my things over it. My TrueNAS over here and, my Proxmox over there, and they all connect over this 1 gig. It's the same 1 gig that I go out to the internet and, I download my watchable Linux ISOs over. And yeah, your performance is going to be very unpredictable and terrible, and it can fall over completely in any number of ways.
Yeah, and even on the bigger enterprise side, I've seen places looking at a small number of machines all like mesh directly connected with 100 gigabit NICs to just save the expense of a 100 gigabit switch, right? If we don't need more than 3 or 4 machines hooked together, we can just wire them all up directly with DACs and not have to pay for a switch because a 100 gigabit switch is stupid expensive.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send in your questions for Jim and Allan or your feedback, you can email show@2.5admins.com. Stu writes, Jim recently mentioned that he has 2 file systems in any laptop, one ext4 for the OS and one ZFS for home and anything else he cares about. I assume Jim is doing full disk encryption, and I have some questions. Do you have to type 2 passwords to decrypt things, one for dmcrypt and one for ZFS? Do you use a key file on the ext4 drive to unlock the ZFS drive? And have you blogged about it or written a guide so I can follow along?
It's a little bit simpler than that because I don't bother encrypting the root partition with the operating system. There's nothing secret there. So I don't really see that it does me a whole lot of good to worry about encrypting that. Like you mentioned, everything that I care about, including my home directory, any data, virtual machines, whatever, those are all going to go on the ZFS pool. So all the data sets that I care about on the ZFS pool are encrypted, and that's all I'm really looking for. So it keeps it pretty simple. I do not use a key file. I use a memorized passphrase to unlock my ZFS encrypted data sets, and that's the way I like it. you can't be legally forced to divulge a secret that only exists in your head. So that's the way I roll.
Yeah, I know some other people, specifically with the home directory part, you can use the PAM plugin to basically have decrypting your home directory be tied to when you log in with your account and authenticate with your account password, that it can automatically decrypt and mount your home directory and then unmount it when you log out. But like Jim said, for any other data sets and stuff like that, the passwords are tied to the data set. And ZFS has this concept of an encryption root where you can have a bunch of different data sets that all use one password to decrypt them. So you don't have to type the same password a whole bunch of different times. But you can also have, one other extra data set off to the side that purposely uses a different password if you want. What makes ZFS encryption so much more interesting than full disk encryption is the ability to have individual data sets be online or offline as you need them, whereas with full disk encryption, it's like you type your dencrypt password before the OS boots, and then everything's decrypted, and it's as if you didn't actually have an encrypted disk as far as the running software is concerned. Whereas with ZFS, you can be like, only the home directory of the person who's logged into the machine is actually mounted right now, and all the other ones are offline. But ZFS can still do maintenance operations, like replace a failed disk, do a scrub, all that kind of stuff, even without the passwords having been entered. And that makes it really, really powerful for more business type use cases or things where you need to be able to destroy data on purpose. Like we did, a lawyer's office who gets a bunch of discovery for a case and has to be able to destroy it after the case is over. And with something like Lux, they would have to make a separate volume with a separate Lux key for every case in order to be able to destroy the data. And with ZFS, it's just much easier to manage having separate keys for different data sets.
And it's very handy for an offsite backup as well. I have my offsite completely encrypted with ZFS, and I send incremental snapshots to it, completely encrypted as raw sends, and it just stays encrypted forever until I need it.
Yeah, the other side never has the key. Unless you go and type in the password at somebody else's house, then that data is never going to be mounted.
Now, that's just rude, Ressington. Don't you know it's standard practice? Part of the benefit of being a backup buddy is you get to browse your buddy's mucky JPEGs.
No. I do give them their own unencrypted data sets to store some of their own files on.
So they get a free NAS out of the deal?
Basically.
And for the question about any written documentation, blog posts, what have you, we can help there as well. I actually wrote a quick start guide on the use of ZFS encryption at Ars Technica during my time there. I still refer back to that when I do ZFS encryption these days because I don't really have to mess with it very frequently. It tends to be one of those one and done kind of deals, and I don't use it everywhere. If the short, straight to the point how-to guide doesn't do it for you, there is also a broader overview of how to use tools like encryption and delegation and replication to up your OpenZFS security that I wrote for Clara.
Yeah, I'll put a link to both of those in the show notes. Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joelrest.com/mastodon.
You can find me at mercenariesysadmin.com.
And I'm at Allan Jude.
We'll see you next week.